What if everything you thought you knew about UFOs was wrong? Most scientists are terrified to discuss the truth behind UAPs, but today we're diving deep into the shocking realities that have been kept in the dark for far too long. Alongside my colleague, Professor Shelley Wright, we'll take on the most taboo questions. Is UFO research all pseudoscience? Is disclosure hopelessly stalled? Do you have to risk your career to study this forbidden topic? Well, not anymore. Astrophysicist Dr. Shelley Wright is now breaking the taboo, risking her reputation by hunting for real-life alien signals. If you're ready for the unfiltered truth on UAPs and the surprising science behind it, keep watching. This conversation will force you to rethink everything you thought you knew about the search for alien intelligence.
Even the scientists were commenting to me, how could you go and talk about UAPs or UFOs? Most people just kind of want to know what's going on. Most people are just going about their lives and they are genuinely curious. And because there's this kind of vacuum about real information, that's where you get kind of conspiracy theories that people with the loud horns can come in and fill that space.
Welcome everybody to an exciting Out of This Universe episode of the Into the Impossible podcast with not only an eminent astrophysicist and not only a fellow professor, but a very good friend. That's Professor Shelley Wright. Shelley, welcome to the Into the Impossible podcast.
Thank you for having me. I'm excited to be here today.
I want to first start off with a discussion about what makes you interested in the research that you do. Explain the types of science that you do, both on the in this world or in this universe, and maybe stuff that might be a little more far out removed from what normal astrophysicists quote unquote do.
I love tinkering and making new instruments to explore the universe in new ways. That's basically it. I love working with engineers, scientists, students to make unique cameras, spectrographs, use new telescopes to really do any discoveries across the universe. And then one of my deep heart interests is the understanding of life in the universe. Are we alone? Is there potentially other civilizations out there? Could they be communicating with us right now in our own galaxy? And if they were, how could we use technology to detect those signals?
One of the things I always talk about that gets me into trouble when I talk about people, I'm sort of an alien pessimist, an alien minimalist, if you will, and that rubs some of my viewers even the wrong way. Some of my friends get really agitated by the fact that I would never say the probability is zero, but looking through how improbable it is that you and I are having this conversation, the fact is we don't have any evidence right now that there are other life forms that rise to the level of many low sigma confidence levels, right? So I think, from my perspective, it would be one of the biggest, if not the biggest discovery of all time, but we always have to temper that with our expectations as scientists should be driven by data. And one of the arguments I want you to react to is people saying things like, well, there's 10 to the 22nd, possible stars in the observable universe. Each one of them could have 10 to 100 planets around them or minor bodies. There's got to be life out there. How do you react to that argument? Do you think it's plausible?
That there's other life out there?
Well, do you think that
we're already proof of one.
Yes.
So I think it's a little hubris to think that we could not be the only one. The question here is in time, and time is what you know well, the age of the universe. And the question really is not whether there's other life in the universe or whether there's other life in the galaxy. Probably a good standpoint science question is there other life that coexists in this moment with us talking right now? And if you put it in that frame, like you think about the Drake equation, which tries to calculate the number of civilizations or communicating civilizations, the leading factor of that is time, right? Like the lifetime of life existing and coexisting with us. So you could take the premise that we are one of that 10 to the 22. That's a pretty boring universe in my opinion, but that is an opinion. And, that's where you need data. But if you take the premise that we should not be the only ones, right? That we were a byproduct, life was a byproduct, bathroom scum is a byproduct, dogs or cats, dolphins to humans are a byproduct of this universe, of our baryonic universe for you, then the question is whether they could exist with us in our own galaxy. Are they existing around other planets that have similar characterizations of habitability like Earth? And then the rough part here in that calculation is, could they potentially be coexisting us in this small sliver, right? Like our technology in this moment is just the tiniest sliver of time in all of the age of the universe. So that, I think time is the most important answer to your question.
Now, you not only knew Frank Drake, you also won the Drake Award. What was Frank like? I mean, he was one of the guests that kind of got away. I never got to meet him or have a conversation on the channel with him.
Frank was a brilliant scientist, obviously a pioneer in the field of SETI, but was a very thoughtful human being, right? Like, he really brought in the importance of science, hypothesis, the scientific rigor to the field of life in the universe, right? Obviously, philosophers, for hundreds of years have been speculating about life elsewhere beyond Earth. But it was really Frank who said, okay, let's bring science to the table and try to answer this question. And he did it for decades, right? And tried to build up a field with individuals. He also shepherded Carl Sagan into the mix, into this field. And he was a wonderful mentor.
Mm-hmm. Now, when people discuss the Drake equation, I always say it's kind of not a real equation, in the sense that I only consider things equations if you can do error analysis on them. And I once did a calculation. Actually, I did it. You helped me tremendously, because you gave a talk at the SETI Institute a couple of months before I gave one 8 years ago now. It's incredible. And I decided, I'm going to do this calculation of how many people are in the San Diego Zoo right now. And if you do it, you can get any number you want, just depending on, is it a holiday? Is it raining like it is today? I mean, can you believe that we had to do this interview in the rain in San Diego? How do you, as a professional and an expert in this field, do you look at the Drake equation? Is it something you take seriously, or you utilize as a tool in your arsenal, or how do you apply it, if at all?
I think we all do apply it in some sense. Like, the Drake equation basically breaks down the constituents of trying to understand the probability of life, which we were just first talking about it. And when they first started with the Drake equation, I always think about that first variable that he put in there, which was actually the rate of star formation. Mm-hmm. So it was presumptuous to think that, okay, you have to have a planet to have life, then planets are around stars. So the question was, how many stars happen within our galaxy? And that was the first variable within it. But then there was things that came later, which they had no idea in the late 60s about, which was like the fraction of stars that have planets, the fraction of those stars that have planets have Earth-like planets, and then the fraction of those that have Earth-like planets with the habitability of it. And what's remarkable in our own careers, Brian, is that we have answered those questions. So I look at the Drake equation, where we march from left to right, where L is the end, that lifetime of civilization we were just talking about, and we're answering them. So in the framework of science and astrobiology, the Drake equation is useful, because we need to answer these questions about how common are planets, how common are Earth-like planets, how common are Earth-like planets for habitability, how common is other life? Mm-hmm. Like, we try to answer these questions, even trying to go to Mars, even other surfaces and planets within our own solar system. And I think we'll continue along that path. On the other spectrum of it, of course, you have biology into place, right? Biochemistry in place, understanding the origins of life, things like the RNA world. How probable is it, if you just have organic material, do you generate life on a surface?
Right.
And that's marching the other direction on the Drake equation. So to answer your question, do scientists sit there and go on the chalkboard with it every day? No, but I think we use it in a framework to answer the big question of, are we alone?
Mm-hmm. So let's talk about what you do in terms of your research activity. Obviously, you're a professor. Now you're the chair of the newly formed...
Substitute chair, interim chair.
Yeah. Okay, you're an interim chair of the newly formed and incubated Astronomy and Astrophysics Department. Congratulations. Talk about your research and how you divide your portfolio. Let's talk about the conventional astronomy, for lack of a better word, and then we'll go into the optical SETI work that you've been involved with for quite some time. So how do you decide on a daily basis, I'm going to do work building a spectrograph or a spectrophoton, whatever you're focusing on that day, no pun intended, versus the work in SETI that you're involved with?
I spend a lot of my time in the lab and trying to build up, like I said, new technology. I really think that's kind of the core of my research and my research group. And that fits into conventional astronomy, where we try to build new cameras, new spectrographs. And I've always interested in being kind of on the forefront of that. So if I look at my career, I was really interested in adaptive optics. When that first came online when I was a student, I said I had to get involved. And adaptive optics, of course, is correcting for the Earth's distortion. It's atmosphere, it allows stars to twinkle. We want to remove them from twinkle and try to get large telescopes to use these. To do that, to take those images that go behind adaptive optics, you have to use pretty close to kind of even our industry limits in detectors, in optics, in cryogenic materials. And I think that's really benefited myself and my research group to take that kind of work and try to synthesize that to make like the latest instruments. And so my day job, so to speak, is building large cameras and spectrographs for large base telescopes like Keck Observatory, and even designing like first light instruments for the even larger, extremely large telescopes. I've spent almost 15 years involved of designing kind of back end instrumentation that goes behind 30 meters or larger of telescopes. And of course, the one that will be coming online is the European Extremely Large Telescope in Chile. But with all of that and my interest in building new technology for these large telescopes, and in kind of the wake of adaptive optics and the detector technology, I was always interested in the search for extraterrestrial intelligence. And the fact that nobody was really doing it, that actually, kind of intrigued me, because it's such a, fundamental question, as you have mentioned many times on this show. So I took the abilities of trying to look at new technology and see what we could do to make new instrumentations for things like Optical SETI. If you come to my lab, you can go into multiple rooms where we're building things for the largest telescopes on Earth, to building completely unique instruments and telescopes that are kind of unique to anything or on Earth, and trying to get them deployed.
One of the things that's so remarkable about the way that you approach your research is that it's not, the pie in the sky, let's build the particle collider the size of the moon or the solar system, diameter, like some of my past guests have talked about and actually honestly proposed. We'll see about that. But you actually do things that are practical, as well as, kind of the stretch goals, and then the more kind of probable or lower risk, but also very high reward in the optical SETI. So let's talk about that. You use something called a Fresnel lens. So let's talk about what was the thought process that led you to design that particular type of instrument. So we have here Galileo Galilei, this little finger puppet guy, and he's holding a telescope. Obviously, he did not invent the telescope. That's a myth, but he did kind of perfect it in a way, and then he made its magnification much better than before he invented the tripod. People don't really think about that, but he really did that. And of course, he made images that revolutionized the way that humans look at the stars. But one of his favorite quotes that I love to kind of bring out with my students, and it's kind of the impetus for what I do, is he said, our job as scientists is to measure what's measurable and make measurable what's not already so. So when you design a Fresnel lens, walk us through that. What was the design choices, the trade-offs, cost, and don't be afraid to be super technical.
This is a great question, because it's how experimental physicists operate. Right? Because we have to take a science question or a science measurable, as you say, and you say, how do I use the current technology to actually build to that, right? So this, our science question or our science objective was to try to image, literally, how do you image the entire observable sky and take a picture at every nanosecond? So every 1/1 billionth of a second, how do you take a picture of the entire sky? And then, of course, the practicality of that is, how do you do that where you could actually afford it? That led us into, it's as usual, a long winding road in design and a lot of dead ends. And we kind of went to traditional telescopes like Galileo, even looking at traditional lenses and refractors, then going to more like Isaac Newton telescopes with mirrors. And we kept going down this path, and it was never really cost effective. You couldn't get these large angles across the sky. And so we needed a way of thinking about how to make cost effective telescopes with large, what we call field of regard. Like, we want to look at large angles. And that's what led us to Fresnel lenses. In fact, project scientist here at UC San Diego, Jerome Mayer, who does optics, was like one of the first to say, let's try Fresnel lenses. We had thought of it. Other groups had thought about it before. And we said, I don't know if that works. Like, maybe we thought they had too poor of image quality. But, those were years past. And we said, well, let's go check out the technology. And so we bought a bunch of them, brought them into the lab, did experimentalists what we do best. Don't just talk about it. We measure it. And we measured the lenses, and they were great. In fact, they were better than we thought, and other people within astronomy had thought. We just had not looked at them for a while. We published a few papers and realized that this was the answer to how to make cost-effective wide field angle telescopes for the science objective we want, right? It's not always going to work for other projects, but as you know, we're always trying to get to our science requirement. In this case, our science requirement was taking a picture across the entire observable sky, and then the even crazier part of the technology is how to do that every nanosecond.
And tell me about the serendipitous kind of alignment with high energy physics and high energy astrophysics. You didn't initially plan on that, right?
Yeah, so we're talking about a project that's called Panoramic SETI, which was trying to do this all-sky observatory. And so each telescope looks at 10 by 10 square degrees. It takes a picture of every nanosecond. We have many telescopes. We are looking for, in this case, optical SETI, kind of what we call pulse pileup, all the light arriving in that nanosecond, which would be very unusual. Stars don't do it. Maybe like submerging black holes, things in, high energy events could happen, but we haven't detected those actually yet. And so we wanted to look for point sources in the sky. We know in this field that if you take a picture every nanosecond at optical light, we get kind of flashes of light that happens from high energy particles that hit Earth's atmosphere. They're called Cherenkov showers. And about every second we get an event. This was noise to us. We knew this. We were making our detectors to take our noise of this, what's called Cherenkov shower, and throw it away. And, another person's garbage is another person's treasure. And we said, okay, we should go talk to the high energy folks to see if they want this information. And they were interested. And we decided to do a campaign where we went to Veritas Observatory in Arizona. Huge dishes. They're amazing. And we set up our PanaSETI telescopes with them back in 2021. And we set them up and to observe at the exact same time, the exact same sources. And the idea was to try to understand the sensitivity we were to high energy events. And the answer is Panoramic SETI was very sensitive and opened up a whole kind of new phase space for high energy astrophysics. So we made a really nice detector that can detect these Cherenkov showers. And this led into a collaboration for our SETI group with high energy astrophysics to now campaign and do both projects.
So now talk about why SETI is different from radio listening, like Drake and others were initially interested in, the Big Ear Project. And then I do want to get back to the Galileo Project and how that's different from what you're doing. But first, let's talk about the actual science motivation. Why would why would you tune it to look in the optical when radio is a lot easier? Speaking as a dumb radio astronomer, it's a lot easier to do radio astronomy in many ways. Why did you just choose, or why do people feel that optical is a promising wavelength range to explore?
Well, so just to comment that, radio SETI, we've been doing that 60 plus years, right? And it's interesting. That was our first technology for, long range communication, right? It's interesting to think of other civilizations would have developed other communication outside of radio. Radio is a great communication because it's low energy, as you know. You can build large dishes and transmit. It's easy to receive. But you can use any, light, whether you're at optical light, radio light, gamma ray light, microwaves, they all travel the speed limit. So in terms of getting to distances from stars, you get there the same amount of time. But why optical SETI? All right. So Charles Townes invented the laser, right? In 1959, wins the Nobel Prize for this. In 1961, he wrote a really interesting Nature paper about how lasers would be a phenomenal way to do interstellar or interplanetary communication. And if you think about this, that's kind of remarkable that this experimentalist invented the laser and then immediately understood implications at a universe scale. And the paper basically argued that with a laser, you can pack a lot of information in it. You can beam it if you know where the person's going to receive it. It is a better carrier of information. It's incredibly bright. So if I sent a signal to you in another planet and you're receiving it, you don't have to build a large dish. Right, you can just build a small dish. And thinking back to Panoramic SETI, we use these very small 20-inch lenses, half-meter size lenses. And even if you do the calculations, you can take Earth's technology today, go 1,000 light years away, take a laser, shine it back to Earth, and our little dish will detect it. That's how bright lasers are. So lasers became this kind of realm in optical SETI as an interesting realm to look at that wavelength. And by optical, I mean visible light. Now, if you're going to send signals, in between stars, there's gas and dust, right? And this is why you probably will say, well, you should probably, if you're communicating thousands of light years away, communicate at radio wavelengths. So, we knew this as SETI scientists, right? So one of the arguments, in fact, is if you were to use a laser or use a beacon that's not at radio, maybe you would do infrared, right? And this led into our team also building another kind of like the first near-infrared SETI instrument, which I was interested in early on, to get to those wavelengths of light as well. But, it's funny, over the years, we always use this kind of anthropomorphic, am I saying that right? Anthropomorphic view of our technology and how we would do detection.
Right.
And if you go out in the public and you give public talks, they'll say, well, how do you know they would use a laser? Wouldn't they use something else? And they would give a word to something probably in science fiction.
Phaser.
Yeah. And you're like, I don't. But light is everywhere in the universe, right? And in truth, we're not necessarily detecting lasers. We can detect anything at visible light that would make a bright flash or look unusual to nature. And everything in SETI is about detecting something that looks unusual, that, natural phenomenon aren't producing. And that's true at radio wavelengths as well.
What are the most significant background or systematic sources of astrophysical contamination?
At Optical SETI, we really don't know yet. Most of the things, I think, for our program, like panoramic SETI, the things that we may detect the most now are like satellites. So kind of Earth technology. We detect a lot of planes, satellites, even people talk about sprites in the upper atmosphere. So kind of local to us. That's true in radio SETI too, right? We talk about radio interference.
Yep.
And most of radio SETI is removing our own Earth signal from that. Yeah. Astrophysically, the exciting part is we don't know.
Would pulsars be something?
Potentially, yes. One of the astrophysics things is we have LIGO, of course, with gravitational wave discoveries. If we have these large angles of field of view, perhaps we could correlate an event that may produce what we call an optical counterpart to it.
Multi-messenger.
But nobody's detected it. Yeah.
And then do you have a protocol, the signal comes in and they're talking with, Proxima Centauri, or you see something of interest. Do you guys have a protocol for what you would do as the PI, as the, what would you do if this comes in? Or is that not for public
No, it's
consumption?
a great question, because we get this question a lot about what we would do, and people have their, sneaky suspicions of whether we get taken away from the Men in Black. We have candidate signals, as you know, in experimental, experiments. You have kind of false positives, as we say, that can occur from your instrument. It's a noise, or it's a signal like a satellite. So we have protocols that do verification. So we have like whether, we flag it like this is an exciting candidate or not. And then we go down and do the checklist to see if it's something internal or if it was correlated with something else. It usually is very unexciting. So we try not to call New York Times in most cases. But the question is, if there is something exciting, we do have a proclamation that we would declare it on Astronomer's Telegram, just like we would for any other transient source, to get other facilities to follow up.
Obviously the question of, the rationale for another civilization to communicate with us. I mean, there's a famous quote from Stephen Hawking where he says, basically trying to message to other civilizations is like ringing the galactic dinner bell.
To serve man, it's a cookbook.
We be cautious and not send out, beacons that say that we're here. I mean, not that that's something you're directly involved with, but what's your position on that type of messaging to extraterrestrials?
Yeah, this is the concept of METI. It's a really interesting ethical conversation, right? There's a twofold question here. One is like, if you think there's a galactic civilization out there, you don't like go out in the forest and scream that I'm right here, right? That's another phrase that's used. That's interesting. Of course, we're constantly leaking. I think more of it comes into kind of an ethical question about representing humanity. And so, as you know, there have been, people with means that go out and have taken radio dishes, taken their favorite rock album and broadcasted it to space. Is that the best representation of humanity? Should there be kind of United Nations protocols about messaging over time? There was a lot of work into the Voyager message on how to represent this and how to represent planet Earth in general. I think we're a little young in our infancy to send out messages, but
and the risk might outweigh the rewards. You mentioned earlier, about looking for, not maybe techno signatures, but maybe just biosignatures from aliens in our own solar system. So I have an argument I'd love to run by you. This is a meteorite. Now this is Chelyabinsk meteorite. I have a meteorite, and I actually have a Martian meteorite that came from Mars. This is not that. This is actually yours to keep, unlike the Martian meteorite. So I'll let you take one of these.
Wow.
So this is a chunk of Argentinian gold. It's actually iron, nickel, cobalt. So, and you too can get it out there. As you know, go to my website, briankeating.com/list or /YouTube or /whatever. Go to /list. I'll actually cut out the YouTuber. So go to briankeating.com/list. And if you're like Shelley and me and you have a .edu email address, you get one guaranteed if you live in the US. So go to briankeating.com/edu and you'll get one, and you'll get some information about that one. Now, that one came here via gravity. I also have one that came from Mars, I said. And, I scanned it for life, never found any life on it. But the point I guess I'm trying to make is the fact that we don't see life on Mars. Okay, it would be a long shot. But can we use the non-observation of maybe technosignatures in our own solar system? Does that set any limits on the fecundity of life in the universe, or is that too limited a scope to project into the rest of the galaxy?
Well, as you know, the cosmos and our Milky Way is vast, and something that's always humbling as an astronomer is the distance between stars. Yeah. I think the only thing you could say is something about interstellar travel and the number of people taking vacations here in our solar system. Now, for Mars, I think more of it's, we take rovers there, as you know, to look not just at like whether life exists now. I would say more of the argument is, did life exist? Yes. Right. So if you look back 3.1 billion years ago, we know Mars had an ocean. We've done a lot of, discoveries about our own surfaces of other planets within our solar system. The question is, if this gets back into the origins of life, now, if we go to Mars and a rover says, wow, look, there was evidence of life 3 billion years ago, that it could start either on another surface besides Earth, that's a very statistical big deal, right? Because it means not only it can just happen on one surface, it can happen on another. And not only that, it could happen on another surface in the same solar system. That marvels me, actually, the most, Brian, because the fact that we can take, our resources today, do things like launch the Europa Clipper and go try to study the oceans of exo moon discovery. I know you had David Kipping on recently. Just thinking about life underneath Europa's ocean or Enceladus' ocean, the moon around Saturn, and thinking about organic materials and what organic materials could be there. That's fascinating to me, that one solar system out of billions, we're contemplating not necessarily, can life coexist just now in our own solar system, but could it have coexisted in the past?
Yes.
Right? We started this whole podcast thinking about, the probability of life. That should be a measurement, actually. That even in our scientific nature here in one solar system, we're exploring potential signs of previous life in other surfaces.
Yes. And when they may have overlap with life on Earth, because life on Earth kicked off.
Well, yeah, we can get to panspermia and other things. Here we go. But take that to all the other planets we're discovering now. James Webb Space Telescope's discovering. It's an incredibly exciting time. And when I started my career, I was always interested in this question of, are we alone? But I remember sitting in classes in undergrad, and people were talking about this rare Earth hypothesis, right?
Book somewhere here.
Yeah, that's. So, even in our little short little sliver of time here, we know that's not true, right? And again, this is marching down the Drake equation.
Yep. So now I want to pivot to a recent, I told my wife that, I saw a star being born when you were on the recent Nova, PBS Nova, which is, not only one of my favorites, one of the oldest, science and nature communications, and it's one of the best and well done. And so your episode was no exception. Talk about the genesis of that, if you will. How did you come to get involved with, PBS Nova, and talk a little bit about the role that you played and the other, contributors to that wonderful episode.
No, I've always been interested in studying technosignatures in this field of, are we alone? And there's actually not that many people in this field, which is one of my things to advocate for, that we need, more brilliant people entering this field of SETI and astrobiology. So when, Congress basically told NASA to commission a committee, a civilian committee on trying to understand, I'll say the word here, UFOs, but at that time it was UAPs. I was asked to serve on the NASA UAP committee, unidentified and then now anomalous phenomenon. Okay. And I said yes, because it was very intriguing that, our government as well as NASA was interested in kind of going into this realm that in our science community is taboo. Yeah. We can talk about, microbial life on Mars, but we can't talk about life in interstellar travel. It's, there's this kind of divide that occurs and a stigma that occurs in the science community as well as public, right? There's like this taboo thing to talk about UFOs and UAPs. And so I said yes, and it was a really fascinating committee to come into it and take a kind of a science data approach to it. I also am interested in using new technology, as I said, to image the night sky. So I was looking at NASA's capabilities with what are called GEOs, their satellites, their geosynchronous satellites. We looked at satellites, Earth observing satellites, and their capabilities of imaging and their angular resolution, the timing and their detectors. And so it was an interesting approach to see what we could detect from the kind of civilian NASA sense and couple that with both what was being seen, by military personnel at the time that was going to Congress, as well as what people see daily, and say what they see in the night sky. So that was kind of where I entered this world of the UAPs. And then I was invited to kind of talk about that experience on that recent PBS NOVA.
Where does the committee stand now? Like, is there a second follow-up report? I mean, maybe you can summarize for those that, may not be familiar with the actual report out. What was the conclusion, or what were, the preponderance of evidence? Where does it come down? Obviously, it's not, that we're definitely being visited, but there were some caveats, and there were a lot of still remaining mysteries that we don't understand.
Yeah, I think there was some misconceptions by the public, because I got a lot of emails about this, that at first they thought, okay, we have a committee of scientists that are going to go in and review every single case that on this date I saw something in the night sky. Our, committee charge was to go in and basically state what is NASA's role and what is kind of interagency US role in how to identify and address UAPs at large. Mm-hmm. And so we were kind of looking at what data existed. We looked at the occurrence rate, like number of people reporting things. We had the FAA people there talking about things that were occurring within the FAA. What are reporting schemes from pilots? We had brought in people that had, publicly disclosed and declassified some things that were done in military, and then looking at that and trying to ask what other data we could apply to these scenarios. And in particular, it was much more forward-looking. So we were looking at how NASA could help with this topic in the future, right? How can it work with the other interagencies? And I think our committee, I'm actually proud of the work the committee did. I think we've seen change that came from it. The first one was even thinking about FAAs, like how do pilots report cases? It turns out, it used to be like in a little, you may know, because I know you're a pilot, but there was a manual and there was a 1-800 number you would call, right, to somebody that you would report to. And so there was a stigma within that. And now there's better reporting for UAPs. And then there was also this ways that communication between the interagencies of the government communicate when a UAP event occurred, and whether you could look at, again, these satellite informations that came from it. And there was a division that started in NASA to look at this case and how it connects to other government agencies like AARO. The other one that I think maybe is probably the most long-lasting is probably trying to break down the stigma. The public stigma on this topic is really important, and the giggle factor that's around it, because there really is a national security risk here. There's a air traffic control risk as well. We looked at the number of drones being flown, looked at the number. I was always surprised by the number of balloon launches per day. There's 10,000 balloon launches per day across the world. A lot of these are industry based. And so it was, just looking at this aerial phenomenon, and it's a great way to tell the public how amazing the night sky is.
To look up.
Right? To look up.
I was surprised, because I talked with several people. I've talked with, pretty much everyone that was in the NOVA episode. Now I've talked to you many times. You're my upstairs neighbor. But on the podcast, Hakeem Olashei, Avi Loeb, Ryan Graves, Mick West, I've talked to everyone. And what really troubles me is the vitriol that I see. And it's primarily in one direction. You don't see many astronomers, kind of railing against the public about their, being ignorant or that they don't accept the fact that we've discovered, some advanced technology. And for example, I had Sarah Scholes on, author, many years ago. She wrote a book, They Are Already Here, which talked about the fact that, 99% of what we saw, and even the report says something like 95% or something, could be explained. And there's all sorts of plausible ways to explain it. But that 5% leaves this ambiguity in the human mind, which we're not comfortable with. And she talks about how the human mind fills in those gaps with sometimes fanciful stuff. But the one thing that stuck out in my interview with her is that she said there's a feeling that the government is maintaining sort of a secret cabal, just as we covered up 9/11, or just as we covered up, the alleged Kennedy assassination, whatever you want to say. I mean, I'm joking about the alleged, but the point being, there's a deep mistrust of government, and then that somehow bleeds through to a concomitant mistrust of you and me as representing big astronomy or big cosmology. I get it, from a different cohort of people when I'm not opining and railing against, those that believe that we're definitely being visited. But I get it from people that say the Big Bang never happened, and that will strike a chord in the public, and people go on Joe Rogan and opine about, or the moon landing didn't happen. How did you react to that? The vitriol, the complaints. I mean, not maybe you don't have to speak about to you directly, but to other members of the committee. I mean, can you talk about what kind of negative impacts that maybe are discouraging to scientists, because you have a million things you could spend your time on? What was kind of the most, surprising thing about serving on this panel as doing a patriotic duty that, I find so commendable?
Yeah, it was surprising. I would have to say that how much, my inbox, I would say, filled up from all corners of this kind of realm, pro, not con, or, even the scientists were commenting to me about accepting this role in the UAP. It encouraged me. It sounds funny to say this, but I think, most people just kind of want to know what's going on. They're not the ones who are, spouting out vitriol, right? Most people are just going about their lives, and they are genuinely curious, right? And because there's this kind of vacuum about real information, that's where you get kind of conspiracy theories. People, the people with the loud horns can come in and fill that space. And I saw it as an opportunity where people that do study the night sky every day, people that do fly airplanes every day, that deal with airspace and think about this topic, could go into this space that's otherwise taboo and fill it with real information, with real facts, with real data. Do we have all the answers? No, but that's science for you, right? And so I took it as kind of an invitation and actually a call to say, wow, there's something going on here. Like, we should be tempering this and using, Occam's razors and rational minds and look at data and investigate this stuff. And that's to the scientists too, because, I think there is, scientists says, oh, good, how could you go and talk about UAPs or UFOs? They would say the word too. And I'm like, well, most of the time people are seeing something, right? And it's a good opportunity to educate them about how fast does a plane fly, right? How many degrees per second is that traversing across the sky? It's going really fast. It's going like a degree or 10 degrees per second. And if you take a video camera with that, you can get weird looking images. So it's an educational moment.
How do you react, just as not an expert in being involved with the testimony, of the so-called, I don't want to say harvesting, but just that they're collections of not only artifacts, but even biologics, according to one gentleman, David Grush. Talk about that as a scientist, as a non-expert in that particular congressional panel. What do you make of that? Like the claims of famous, book came out. Lou Elizondo wrote a book about imminent disclosures, imminent. What does that sound like to a professional scientist, an astronomer who's got, as you and I are talking before we started recording, we would love to have, be visited by aliens as long as they're not going to eat us, and they'd probably, eat me before they'd eat you. But the point is, how do we handle these kind of seemingly outrageous claims of spacecraft that are bigger inside than they are outside, and biologics and things like that now we're having panels, a congresswoman in Florida is investigating this in all seriousness. So how do you as a scientist react to such things?
Well, I think that will always be there, and it persisted before, this became kind of a lightning rod topic in the last few years. There's always been stories of this, and there always will be, right? And there's always your, extraordinary claims requires extraordinary evidence, and that will always exist for myself as a scientist. People could come forward and say what they see, and there's ways to investigate it, right? And we don't have to get overly excited about every time someone walking forward and claiming things like this. So I'm not bothered by it. And again, I think it's an opportunity that shows that we need to educate the public more about what's happening. Now, regarding the conspiracy theory aspects of it, I think that will, again, always be there because there's reasons why things are secured, right? that things move forward. This is nothing new. It's been around since Roswell.
Yep. Yeah, no, I appreciated the discussion on the Nova special about Roswell and putting it in context. I mentioned the Galileo Project, past guest, many time past guest, Avi Loeb, and his Galileo Project is doing something different. It's also looking in the optical, but it's doing other things like listening for audio signals and compare and contrast, Pano SETI with what they're looking for and what kinds of complementarity or multi-messengerness you might enjoy with them.
Well, I don't know all the details, of course, about the Galileo Project, but of course I think they're trying to look for aerial phenomenon that's in Earth's atmosphere. So one of the striking differences, since we talked about kind of science requirements and experimental, we're looking for things that are astrophysical and far away. And so the way we design our instruments are different. The aperture sizes for the Galileo Project are really small at visible light, right? They're kind of like, think about fisheye, all sky cameras. Yeah. So you can think about sensitivity of that. I think they also use radar. And the way that they image the sky is very different than the projects I was talking about, where we're trying to do something very extreme, which is this nanosecond, microsecond time regime. That's actually interesting because we do detect aerial phenomenon, but that's not our goal. In fact, I have a student here, undergrad, because I love, part of the joy of also running a lab here at University of California, San Diego, is working with the students and educating and getting people excited about the topic of life in the universe. But this student is working on trying to detect and correlate airplanes and satellites in real time to what's registered. And so we do track some of those aerial phenomena.
Flight aware. And
but it's a completely different project, different technology, different science goal.
That's exciting. And a couple things to close with. One is, there's a famous quote from Winston Churchill that I really like. He said that he succeeded because he proceeded from failure to failure without loss of enthusiasm. When you come against evidence that maybe disputes or refutes your hypothesis, how do you know when to stop? Like, how do you know when to turn off an experiment? And I want to segue that into something that the general public can maybe glean for their benefit, which is, how do you know when you're wrong as a scientist? Because a lot of, I read some study, and my audience hates when I mention it, but if you exclude the times when Venus is above the horizon, UFO sightings in America go down like 70%.
Yes.
Okay. Now, you would think that would diminish their enthusiasm a little bit for then claiming that, there are actually UFOs and we're just covering it up. Or when you see these recent drone sightings in New Jersey and they've got a flashing red light on the right wing and a flashing green light on the, that's exactly what all airplanes have in America and around the world, actually. So how do you know when to, kind of close the books? Or can you say, well, we just don't know enough and we'll always keep searching? How do you as a scientist, and how should the general public know when they've been falsified?
The thing is, for SETI, like, everyone I meet thinks scientists do this, but we don't. Yeah. As you know, there's only I think I once testified, there's only 24 dedicated.
There's more in the NBA in Los Angeles than
so that's always shocking me. So the answer is that there's so much phase space to study. We talked about wavelength coverage and radio and visible light and infrared. There's new technology to do exploration for it. When you start an experiment like this, the reason why this is so interesting to me is that we haven't designed an instrument like this. We don't know what we're going to detect. Do I think we're going to detect interstellar communication? I always temper that with my students. No, we're not going to detect that. But nobody's ever looked. And as we've learned, usually in history, what we've learned is that if you look at the universe in new ways, you usually discover something interesting by the natural world. Mm-hmm. And so I don't know if we'll detect anything. I think for this, you have to run it for the amount of time we say we're going to run it. So as you know, we provide limits. Okay, you do this in cosmology. You say, I'm going to observe this amount of time to get to this limit. You know this very well. Mm-hmm. We do similar things. We try to apply to some sensitivity limit to that experiment. For myself, in this phase space of experimental SETI or experimental technosignatures, this is an exciting time. You can go in any other area, either archivally search or build a new instrument. Right. So there's no shortage of phase space there. And, Jill Tarter always equates it with us walking down to La Jolla Shores here with your pint glass and scooping out water of the ocean and looking in the pint glass and saying there's no fish in the pint glass, therefore there's no fish in the ocean, right?
Although I told her, if you don't find some microbes in it, there's something really wrong.
Well, right? That's true. But, it's the same thing, like that analogy of the pint glass to the volume of the ocean. Yeah. Because comparatively to everything else we've done in astrophysics. It's nothing.
Yeah, it's minuscule. Well, Shelley, I always like to conclude the podcast by asking a kind of existential or deep question. I want to ask you one that ties into the name of the podcast, Into the Impossible. It comes from Sir Arthur C. Clarke's famous saying that the only way to discover the limits of the possible is to go beyond them into the impossible. And I want to ask you, as someone who's done just incredible things, I always say that one of my highlights of my career is that I was on the committee to hire you 10, 15 years ago. I can't believe it. And you brought so much renown to this institution. What advice would you give? You got 20 seconds, 30 seconds with a 25-year-old Shelley Wright. What do you say to her? What do you tell her to give her the courage, to give her the inspiration to go into the impossible as you've done?
Authenticity. It's a short life, and try to follow what drives you as a scientist. And we're talking about science here as well, but passion is what pursuits you want to pour your energy into. For the impossible portion of it in science, I would say, take some risk. You commented on, your Winston Churchill quote, which is totally true. Most of science is failure. Every day we're running into dead ends. And I think to really do cutting edge science and get to the forefront of discovery, you have to take some risk. Yeah. And I would say, don't be afraid of that.
Shelley Wright, thank you so much for being here on the Into the Impossible. I hope we have you on many times. The appearance now, you got your SAG-AFTRA card probably for this wonderful appearance at PBS Now. We'll have links to that. We'll have links to your website and your talks at SETI Institute that are so amazing and inspirational. Thank you so much for everything you do and for coming on the show.
Yeah, thank you for having me.
Great.
Thank you.